Good morning, everybody. My name is Wacharamanotham. On behalf of my colleague Krishna, Subramanian, Sarah Therese Fokker, and Jan Borchers, I would like to introduce you to Statsplorer, a system that will help users doing and understanding statistical analysis process. I'm very confident that all of us in this room know how to do inferential statistics. Let's recap a little bit. First, you formulate your hypothesis, collect and pre-process your data. You plot the data out to check for outlier or bimodal in your data. Then you select statistical tests among a few choices like ANOVA, t-test, Wilcoxon rank sum test, Wilcoxon rank test. These are all easy, right? And then you check for statistical assumptions such as normality or homogeneity of variance. If your data does not match the statistical assumption, then you have to just go back to choose your test again. After that, you run your statistical test, and in some cases, you run post-hoc test. Remember that Bonferroni correction. Then you interpret the results. Of course, we do not only follow only p-value, but we also interested in effect size, such as difference between mean, coherence d, eta square, and everything. And then of course, you have to write your report. Don't forget that R2 remind you to include confidence interval in your report because it is recommended by APA standard. So I'm very confident that everybody in this room have done all of these steps like in your head and everything is fine. However, Paul Keynes found that in his survey in 2007, surveyed some leading journals in SCI, including Tokai and SCIJ, found that 60% of the sample papers still have some problem in reporting. For example, missing some information that would allow the user to infer from statistical results. 36% of the paper miss some statistical assumption or use the data that violate statistical assumptions. Lesser, like 34% of the paper, did overtesting. This is the case when you perform multiple t-tests on the same data set, while you should actually perform ANOVA instead. 20% used inappropriate tests, for example, mixing between parametric tests and non-parametric tests in the same data set. You may think that, maybe it is the problem of SCI. We have so wide community, many people do statistics. Let's take a look at medicine domain. A survey by Stratsak and his colleague showed that medicine domain have 96% of the paper from Nature Medicine in 2006 that have reporting problem. Other problems are also similar to SCI as well. But all of these that we have seen so far is just a tip of the iceberg because there are a lot of papers that were rejected because of statistical analysis ground. Therefore, we don't want to waste time and resource of the reviewer, of the authors to work on that statistical analysis. Many systems and related work have tried to solve this problem. For example, visualization software such as Tableau emphasize visualization of the data to allow people to see the problem that is inside the data set itself. Software such as Vista allows the user to see the process of statistical analysis by visualize them in the connected graph. Software such as StatWing automatically select tests based on predefined heuristics. And software such as AdviceStat generate reports such that the user can copy and paste and use in their paper. Statsplorer combine all of these features, principle of the software together in order to allow the user to perform statistical analysis and also understand the process of statistical analysis. We have two use cases. The first use case is maybe one of us, or maybe I or you. I'm a researcher and I want to analyze my data, and user can use Statsplorer to analyze his own data. Or your students or remember the time that you were young, that we learning statistics. Statsplorer can help them learning the process of improving process of statistical analysis as well. Let's take a look at the first use case through a small walkthrough. Since we come from Germany, we cannot help by just bringing the worst case scenario. We are so interested in sausages. Suppose we have a small data set. This one is from Consumer Report of the amount of calorie and sodium that are in 3 different types of sausages: beef, pork, and poultry. What you will do now is to upload the data into Statsplorer and sausage.csv, and you can select the row whether this variable is independent or dependent variables, and whether it is ordered or unordered and interval and has equally spaced interval or not. Now the fun starts when we start the analysis. Let's say that we want to know the distribution of calories among these sausages. We first click in calories. Statsplorer automatically chooses the visualization in order to review the characteristic or potential problem in the data. In this case, it shows histogram of the calories and histogram of the calorie of all sausages. Let's say that we want to compare different whether different sausage type have different calorie or not. So we click on type. Statsplorer now see that you choose one independent variable and one dependent variables. Therefore, it chooses box plot that allows you to see at a glance the comparison between these types. Users can also hover over the box plot to see descriptive statistics. Let's move on. Now we want to test for the difference among these three types of statistics. The user can select the mean of each sausage type and then click compare. Statsplorer automatically tests necessary statistical assumptions, and based on this test, Statsplorer chooses for us one-way ANOVA. What you can see now is that we emphasize the usage of effect size by allows the user to interpret effect size better. By hovering over effect size, we show the gauge whether the current effect size is in small, medium, or large. In this case, we got a medium effect size for the calorie difference across the sausages. Furthermore, Statsplorer generates reports. Next, please. Statsplorer also generates textual report in the format that is ready for you to copy and paste in your paper. We ensure that the report have all information that are needed in order to infer statistical results based on the APA standard. And we can also do follow-up post-hoc tests. And what we found here is that beef and pork does not differ much in calorie. So if you want to eat sausage tonight, go for something that comes from poultry. Now, yes, you can see Statsplorer solved the reporting problem by generating report. Now let's have a look at others problem. We have seen calorie, but now let's take a look at the difference of among sodium among sausage types. Now we compare between beef and pork. Oh, there is something red there. Let's take a look. It seems that this data is not normally distributed in the pork type. Therefore, Statsplorer choose Mann-Whitney U test in order to perform the test of difference here. The user can click in the statistical assumption, and we provide basic diagnostic plots such that the user can know that, okay, according to this histogram, pork seems to be not normally distributed, maybe because of the outlier that we've seen there. Because of this, Statsplorer choose Mann-Whitney U test that allows the user to do the statistical test. And as you can see here, Statsplorer help in statistical assumption and appropriate testing by providing automatic test selection and explaining test selection in the decision tree. Lastly, let's try to compare the rest of the pairs. Now we already compare beef and pork. Let's compare beef and poultry and also pork and poultry. Oh, there is some problem happen. Because we have compared between all of the levels of the types of sausage, what Statsplorer detect is that you may attempt to do over-testing, perform multiple pairwise tests instead of performing one multivariate test. Therefore, Statsplorer suggests that you should fix this by performing multivariate tests. We are going to click on that. And Statsplorer perform multivariate tests for us. In this case, the Kruskal-Wallis test does not find a significant across the type of sausages. Therefore, post-hoc test options are not offered to the users. And this is how Statsplorer try to address the over-testing problem. In the evaluation, we are interested in how users actually learn from Statsplorer. Therefore, we compare Statsplorer with a lecture with 2 research questions. The first research question is that is Statsplorer versus lecture, which one is better in yielding test result? And the second research question that when should we use Statsplorer? Should we let novices that don't have any knowledge at all use Statsplorer before the lecture to prepare, or should we have them use it to practice after the lecture? And this is our setup, ABBA setup. Half of the participants use Statsplorer before the lecture and other half attend the lecture before. And this graph shows a result of the comparison. What you will see here is that if the data go towards your right-hand side, Statsplorer is better. If the data go towards your left-hand side, lecture is better. In the overall test, we start with the same level of knowledge across 2 groups. In the mid-test, we found that users who use Statsplorer performs better in the test than lecture. When we break down into the questions that consist of these 4 problems, we found that the most outstanding aspect is reporting, that students are able to answer questions correctly in reporting better than other aspects. When comparing between effect of preparation and practice, we see the result is less clear. Although in the 3 aspects, statistical assumption, over-testing, and inappropriate testing, the users will perform better. The user that use Statsplorer to prepare perform better than the user who use practice. In reporting, the performance kind of degrade. And a qualitative study that we have do a follow-up informal case studies show that students tend to rely on the reporting function, and they did not remember what should I include in the report. Therefore, the knowledge decay pretty fast. So to address in addressing the 4 problems, we found that Statsplorer allows the user to have a better short-term retention in the reporting aspect. Our students prepare better with Statsplorer in regard of statistical assumption. But in the over-testing and in inappropriate testing, although the result is positive, it is still not clear. What you have learned today is a system that allows you to perform statistical analysis and learn statistical analysis. We implement this system in R and HTML, which is extendable. We will open source this system. If you are interested, you can follow up in this URL. But if you cannot wait, you can just go to interactive activity today. I will be waiting for you at booth H3. On behalf of my author, I thank you for your attention, and I would like to hear your comments, suggestions, or job opportunities. Thank you.
Hi, Matt Kay, University of Washington. This is really cool. I love this a lot. I guess one of the things that I want to ask you about is how you think this works when you're trying to take people from sort of novice to a couple more steps up the ladder. And the reason I ask that is that a lot of statisticians kind of balk a little bit at doing things like using formal tests for normality or homogeneity of variance because they tend to be not sensitive in small sample sizes and oversensitive at large sample sizes, and tend to prefer things like using domain knowledge to know what distributions you should expect, or doing sort of plots that will help you assess model violations. And so I'm wondering how you get people from this starting point to something more like that.
That is a very challenging study to perform. I don't have definite answer for you yet, but what we are trying to do in Statsplorer is we're trying to progressively disclosure related information for statistical tests. What we don't have, we did not show here, is that we have help that allows user to see more. Why is that happening in that way? Why is this test being chosen, and so on and so forth. One of the future work that we have is we want to use Statsplorer to kind of scaffold the R code that you can use for further analysis. And if the user are interested in statistical analysis, they can take this scaffolding and then like modify it and play around with it to learn more about statistical analysis. Of course, we don't want people to stick with Statsplorer all the way through, right? Yeah, that is a good comment.
I love it. Thank you very much.
Hi, Steve Harrose, Northwestern University. Really, really cool system. I'm wondering, though, a number of different journals have very different statistical requirements, right? Some have just outright forbade any sort of ANOVA whatsoever.
That's true.
Do you have some sort of like a pluggable system where each journal could make like their own thing for what their requirements are?
Mhm. That is a very nice idea. The current architecture of this version of the software does not allow you to modify much about the format of reporting that you have, but we are working on the next version that will allow you to change the format of requirement of the report, and also like doing other type of statistical analysis, for example, estimates-based analysis or Bayesian analysis.
Cool, thanks.
More questions? We have time for questions. Well, I have a question.
Yep.
So in your paper you write that, I mean, first of all, great talk, and especially the reporting function seems to be very nice. So in your in the paper you write that people looked at the report immediately and like found this really nice. So I was wondering, how do you value this, the visual exploration of looking at the charts, looking at confidence intervals? Do you have any idea how students were doing this, how students were evaluating this, how you think of teaching students to do so?
In our user study, we actually let two students do constructive interaction, interact with the graph, and try to answer the research questions that we have. We record the screen recording, and then we analyze the video and code the video. We found that students who are actually use Statsplorer before the lecture, they tend to be eager more to explore and to figure out what are these things in the system more than students who use Statsplorer after the lecture. Maybe that is a clue that if we have a system that allows novice users to be able to explore statistical details, then that might be something that to look further into. But we haven't dig deeper into detail because our study have a very tight session, 45 minutes for using Statsplorer. We are looking into a long-term study on this. Yeah. Thank you very much.
Okay. Yeah.